Okay, so in this video, we are going to be discussing absolute value. The definition of absolute value is the distance a number is from 0. So when I take the absolute value of 3, the reason we get the answer as 3 is because the number 3 is 3 units away from 0. When I take the absolute value of -2, the reason the answer is 2 is because -2 is still 2 units away from 0. Absolute value is always going to be positive because when we talk about distance, we talk about positive values. So when I have an absolute value equation, what I'm really asking is what number is 4 units away from 0? So of course in your head you're thinking, well, 4 is 4 units away from 0. 1, 2, 3, 4. So x could possibly be 4. Some of you might realize, though, that another number is 4 units away from 0. -4 is 1, 2, 3, 4 units away from 0. So another possible solution is that x could be -4. To check our solutions, we can plug in x to our equation. So is the absolute value of 4 equal to 4? It is, so that works. We ask ourselves, is -4, when I take the absolute value, is that equal to 4? And it is. So we have two solutions. X can either be 4 or it could be -4. So when we solve absolute value equations, we need to ask ourselves, what does x minus 3 have to be equal to so that when I take the absolute value of it, I get 8? Well, one possibility is that x minus 3 could be equal to 8, because if x minus 3 is equal to 8, then the absolute value of 8 equals 8. The other possibility is that x minus 3 could be equal to -8. Because if x minus 3 is equal to -8, I end up taking the absolute value of -8, which is in fact 8. So I really have two equations I need to solve for. I solve the first equation by adding 3 to both sides to get x equals 11. I solve the second equation by adding 3 to both sides to get x by itself, and I also get x equals -5 as a possible solution. So two values that make this equation true are x equals 11 or x equals -5. To check that, I can plug in 11 to my original equation to see if I do in fact get a true statement. 11 minus 3 is 8, and the absolute value of 8 is 8. So 11 is a solution. I can also check to see if -5 is a solution by plugging that into the original equation for x. -5 minus 3 is -8, and the absolute value of -8 is in fact 8. So both 11 and -5 end up being a solution to my equation. Here's a more complicated example that you saw in guided practice number 4. The goal here is to get the absolute value by itself, so I can set up my two equations. In order to get that absolute value by itself, you solve for it just like you would when you solve a regular equation. Consider the thing in the red box to be x. I need to get rid of the -5 and the multiplying by 4. So to solve, I'm going to add 5 to both sides, and I'm going to get 4 times the absolute value of t plus 9 equals 24. I still need to get the absolute value by itself, so I need to divide both sides by 4. And so now I have my inequality, or my equation, t plus 9, the absolute value of it, is equal to 6. Now I can set up my two equations just like I did in the last problem. So the absolute value of t plus 9 is equal to 6 can be broken up into two equations. The inside of that absolute value sign, if that's equal to 6, then I'm going to be taking the absolute value of 6, which is 6. If the inside of that absolute value symbol is equal to negative 6, I'm going to end up taking the absolute value of negative 6, which is also 6. So these two equations give me what I need on the inside of the absolute value symbol. So again, solve just like a regular equation to give me t equals negative 3. I'm going to solve the next equation. As usual, subtract 9 from both sides to get t by itself, and I'm going to end up with t equals negative 15. So these are my two possible solutions to my equation, which I can check just like I did before by plugging in the values for t, a solution. So here was my original equation, 4 times the absolute value of t plus 9 minus 5 equals 19. So let's first check our answer, negative 3. 4 times the absolute value of negative 3 plus 9 minus 15 should equal 9. Sorry, minus 5 should equal 19. If I simplify my grouping symbol first, remember GEMS, grouping symbols come first, or PEMDAS, they kind of act like parentheses. 4 times the absolute value of 6 minus 5 needs to equal 19. The absolute value of 6 is 6, so 4 times 6 is 24, minus 5 is in fact 19. So my first solution, x equals negative 3, works. If I take and plug my second solution, which was negative 15, into my equation, I get the following equation. 4 times the absolute value of negative 15 plus 9 minus 5 equals 19. Again, simplify what's inside of the grouping symbols or the absolute value symbols first. So I get 4 times the absolute value of negative 6 minus 5 equals 19. The absolute value of negative 6 is 6, so 4 times 6 is 24, minus 5 does in fact equal 19. So by plugging in negative 15, I get a true statement on both sides of the equation telling me that negative 15 is in fact a solution.